Hello everyone, welcome to another video in the ACT Math section. Today we'll be going over the elementary algebra content area. This is your second content area on the ACT Math exam. So the first topic that we're going to go over is polynomials, specifically adding, subtracting, multiplying, and dividing them. So let's go ahead and get started with adding polynomials. What does adding polynomials mean? So first off, let's define what a polynomial is. It's basically an expression that has variables and numbers. So like 5x plus 5, that's a polynomial. 3x squared plus 6x plus 2, that's also a polynomial. So when we're adding polynomials together, what we want to do is we want to combine like terms. So for instance, let's say we have 2x squared, and I'm putting these polynomials in parentheses so you can see them a little better, plus 4x plus 5, and then let's say we're adding this to 2x plus 3. When we're combining like terms, that means constants get added to other constants, variable terms get added to other variable terms of the same degree. Degree just refers to the exponent of that variable. So like we have an x to the first power here, and this will also be an x to the first power. So these, you'd be like adding these terms together because they have the same degree. So what you can do is you can kind of line these polynomials up vertically if it helps you visualize it a little better. So it's 4x, 5, and then plus, we have 2x, and then 3 here. So we're adding basically. So 5 plus 3, right, that gives us 8. And these are all positives, so we can actually keep the plus signs here so it's a little easier to understand. Plus, then we go down 4x plus 2x, that gives us 6x. And then there's no x squared term here. You could honestly put 0x squared if it helps you, just so that you have something for each column. So 2 plus 0, that's obviously 2, so 2x squared. That's basically what you have to do when it comes to adding polynomials. You're just making sure you're combining like terms, constants with constants, variables with variables. All right, subtracting polynomials is pretty much the same thing. I'll keep the same example just for time's sake. Let's say we're subtracting here this time. So we're going to change this outer one to a minus sign. So now we're basically doing, and I put this in parentheses so that way you're applying the negative to each term basically. So 5 minus 3, right? That gives us positive 2 here. And then let's say we have 4 minus 2, 4x minus 2x, so that's going to give us positive 2x. And then 2 minus 0 still keeps us at 2x squared for our x squared term. So adding, subtracting is very simple. Multiplying, dividing is a little bit harder. So when we have an x squared term, when we have 3 terms in a polynomial, we call it a trinomial. And when we have 2 terms in a polynomial, we call it a binomial. When you're multiplying polynomials on the ACT, more often than not, you're multiplying binomial by binomial. I don't think you're going to get one where you're multiplying trinomial by trinomial, but we'll work through one just so that you guys are able to know it just in case it comes on the exam. But let's first start with a binomial times a binomial. So let's do 3x plus 5 times 2x plus 1. So we're going to follow a strategy called FOIL. What does FOIL mean? It means first, outside, inside, last. So first, right, that's going to be these two, the first terms in each binomial. The first terms in each binomial, so that's 3x and 2x. That's what we're going to be multiplying first. This signifies RF. All right, then the outside. So what terms appear on the outside? 3x and 1. That's on the outside because it's the first term of the first polynomial and the last term of the second polynomial. Those are the ones that are like on the outside. They're like the furthest apart from each other in a way. So this would be your outer. And then inner. What does inner mean? What are the 2 terms that are the closest together? 5 and 2x. The second term of the first polynomial and the first term of the second binomial. So this would be our inner. And then last. Well, what's the terms that we haven't multiplied yet? The two constants. Those always come last. So 5 times 1. This would be our last. All right, perfect. Last. All right. So now let's go ahead and multiply it in the steps. So let's start with first, to start, 3x times 2x. You're multiplying the exponents and multiplying the constants and multiplying the variables together. You're going to get 6x squared. Because remember, these are x to the 1 power. When you multiply two variables together, you're adding the exponents. So 6x squared plus, now let's do our outer, 3x times 1. That's just going to be 3x because it's times itself. And then we have inner, 5 times 2x. 5 times 2 is 10. So it's going to be 10x. And then our constants at the end, 5 times 1, that is going to be 5. And then what we can do to simplify it is combine our like terms here because they both have, they're both x terms. So you're just adding the coefficients. So we're going to have 3 plus 10, which is 13x. So 13x plus 5. So that would be your answer for this problem. So this is how you want to approach binomial multiplication. Again, you're going to see this the most often. I really doubt you're going to see any trinomial multiplication. But if you do trinomial multiplication, we'll quickly go over it. If you do get a question like that on the ACT, you can't use foiling. Unfortunately, only FOIL works for binomials. So you're going to have to do like a grid method. So like, for example, let's say we have 2x squared plus 2x plus 5. And we want to multiply this by 3x squared plus x plus 2, for example. So we're going to take the terms of the first polynomial and we're going to put it like on the top of like this imaginary grid in a way. 2x and 5. All right. So like the top row almost. And then we're going to put the terms of the second polynomial on this outside left column. So 3x squared, x, and 2. So now here's what we're going to do. We're basically going to multiply, if you can imagine like a grid. And I apologize if my lines are not super straight, but it should still get the job done in a way. If you imagine we have this grid, all right, it's a very poorly drawn grid, but it should help in terms of just understanding what I'm about to illustrate. For each box, basically, we're going to be multiplying this term, like the term in the top row, times the one in the outer column, right? You're basically multiplying each term of each polynomial by its respective term in the other polynomial. So here's an example. This top left square, the one that my cursor is in right now, it's bounded by 2x squared and 3x squared. So we're going to multiply these together. So 2 times 3, that gets us 6. When we do x squared times x squared, we're adding the exponents, so we get times x to the 4. Here we have 3 times 2 is 6, x squared times x is x cubed, and then 5 times 3x squared is 15x squared. So this is what I meant when I said, like, you're taking basically this term, and you're multiplying it by each term in the other polynomial. All right, then we have, let's do the x terms now. So 2x squared times x, that's going to be 2x cubed. 2x times x is 2x squared. 5 times x is going to be 5x. And then finally, at 2 at the bottom here, 2x squared times 2 gives you 4x squared. 2x times 2 is 4x. And then 5 times 2 is 10. And then to simplify it, you would basically want to add like terms. So these are your like terms. Nice thing about this is your like terms are always going to be like diagonal to each other. So here are all your x squared terms. And then here are all your x terms. So when we simplify it out, we have 6x to the 4th plus 6x cubed plus 2x cubed gives us 8x cubed. Plus 15x squared plus 2x squared plus 4x squared. 15 plus 2 plus 4, that gets us 21. X squared plus 5x plus 4x is 9x plus 16. So again, I don't think you're going to get this on the ACT, but if you do, you know how to do it. All right, and then let's go over dividing polynomials. So there is something called synthetic division, where you're basically dividing a polynomial by one of its factors. We're going to get to that in a later video. And in terms of long division, it's just polynomial long division. Typically, you'll have something like, typically it'll be a trinomial divided by a binomial. I don't think you're going to get anything harder than that. So I'm just going to make up a problem here. Let's say we have x squared minus 8x plus 8 over x minus 2. Okay, yeah, that works. Okay, so what we're going to do is, this is our divisor, this is our dividend. So x minus 2, and then we're going to have x squared minus 8x plus 8. All right, so what we want to do is this, right? Let's first look at this x squared term by itself. We're dividing x squared divided by x. What does that give us, right? Remember, when we're dividing variables, we're subtracting the exponent. So it's like x squared divided by x to the 1 power, or x to the 2 minus 1 power. So that's going to leave us with just an x. There's a reason why I'm putting it here. So now we need to apply this to, we need to first do x times x to get you minus x squared, right? Because that's the term we're trying to cancel out. And then you need to do x times this negative 2 here. So negative 2 times x is minus 2x. And I'm putting this negative sign here on the outside to show, because that's what we're trying to do. We're trying to cancel out this term and move on to the next, division problem. So negative 8 minus minus 2, or negative 8 plus 2, is going to give you negative 6x, right? Okay, so now we're going to do the same thing like we did initially. Negative 6x divided by this term on the outside, x. So what does that give us? That just gives us negative 6 by itself, right? So the reason why I'm putting it x minus 6 here is so that it lines up basically. So now we're going to do negative 6 times x. That's going to give us negative 6x. Remember, the minus goes in the outside because we're trying to cancel out these terms. And then minus 6 times minus 2, that gives us plus 12. Make sure to also bring this term down as well. So plus 12, like this. All right, so this goes away. 8 minus 12 gives you minus 4. Okay, so now we're going to stop dividing because we can't do negative 4 divided by x, and we're not going to get a integer value or a variable term. So negative 4, that is going to be our remainder. That's what's left over. I purposely tried to pick the factors like these so that we didn't get a factor 1, so that way you'd be able to see how we would write our quotient and our remainder. So this is our quotient here, x minus 6. And then minus 4 is our remainder, but we have to do it like this. It'd be minus 4, I'd probably put this in parentheses so it's easier to see. Minus 4 over your divisor, x minus 2. That is how you would write the answer for this. It's not minus 4 by itself because you're still dividing this by x over 2. So this would be your remainder for this problem. So x minus 6 is your quotient. Negative 4 over x minus 2 would be your remainder. All right, awesome. Let's move on to the next topic. Factoring polynomials. Okay, awesome. So when we're factoring polynomials, it's typically going to be trinomials, and you're factoring it into 2 binomials. So it's the opposite of FOIL, but you're going to be doing completely different steps. So let's say we do x squared minus 12x plus 35. Let's say we get this polynomial, and we want to factor it into its respective factors. So we're trying to factor it into 2 binomials. So the first thing I want to do is kind of understand what each term represents in terms of how we're going to be using it to factor. So this leading coefficient, we have a 1 here. These are the easiest types to factor. We don't need to worry about that right now. This means that having a 1 here for your x squared, like you're just having x squared by itself, that automatically means that your first term in each binomial is going to be x by itself, right? Remember, first, that is what is getting us that first term in that trinomial. The only way you get x squared is x times x. There's no other combination you can do, at least with binomials, that it's going to work. So x times x, that's your only combination. So this is why these are the easier ones. Once you start having leading coefficients here, it gets a little trickier. We'll go over an example of that in just a second. All right, so how do we interpret these other coefficients? We're focusing on just the coefficients right now. So if you remember from when we did FOIL, right, this last term came from us multiplying the coefficients together. So that means that our two factors are going to multiply together to give us positive 35. So let's first go over the factors of 35. What factors do we have? Well, 1 and 35 and 5 and 7. That's it. Those are the only factors we have for 35. Obviously, 7, 5, 35, and 1. But those are the only unique factor pairs that we have. So then now we're going to focus our attention on this minus 12 here. Remember, this is our outer and our inner. So this is the one where you're almost like you're adding the two terms. Like you're adding the two factors together, and it should give you that negative 12, basically. One of the things that is important to note is remember that since this is positive, you could also have the negative version of these as factors. So you could have minus 1 and minus 35, or minus 5 and minus 7. That makes sense because when you multiply these factors together, two negatives make a positive. You're still getting positive 35. So if I do, we're going to just ignore this minus sign for right now. And in fact, this actually tells us that our two terms, our signs are going to be minus for both the binomials. Does 1 plus 35, does that give us 12? No, it doesn't. So that is out for sure, both the positive and the negative version. 5 plus 7 does give us 12 though. And remember, since it's negative, it's going to be this negative version. We already took care of the minus signs, so we're just going to put in 5 and 7. You could put 7 and 5, it doesn't matter because it's multiplication. But that's how you would factor out this trinomial. So now let's going to try one with a leading coefficient, make it a little more trickier. So let's say we have 2x squared. Thinking of a problem. Do plus. Let's do plus 8 on the outside, and then let's do plus 8x. Oh, I do not want to do this one because this one is going to be a one you can factor out. Okay, let's do 3x squared. I'm trying to think of one that is like you can't factor out a GCF because obviously in the other one you could factor out a 2 and you'd be able to get it down to an easy one with no leading coefficient. Which, by the way, if you do find a GCF when you're factoring out trinomials, make sure you do like take it out so that way it simplifies your factoring. But I'm trying to get one where you don't have a common GCF with the terms. Let's go with plus 6. Oh, no, this is not going to work again. Okay. Plus 15. Okay, yeah, this would work. All right, perfect. Yeah, this should work. Okay, sorry about that, guys. I wanted to make sure I get you guys a problem that you can't factor out a GCF, so I had to think in my head. So, no GCF, you can't factor out anything because there's no common factors other than 1 between these numbers. So, we're going to have to factor. Now, I picked a nice one. Your leading coefficient is not, having any other factors except 1 in itself. It's a prime coefficient. So that means your only way of getting 3x squared is going to be 3x and x, right? If you do have a coefficient that does have, like, let's say 4x squared, where you can make it like, it could be 2x and 2x or x and 4x, it gets a little bit more trickier. If I can think of a problem, we'll try to do one. But I struggled just trying to get this problem off the top of my head. So, yeah. All right, now let's move on to the factors of 15. So what are factors of 15 we can use? 1 and 15, and then 3 and 5. So let's say, okay, so hold on, let's think. So it's positive here, and it's positive here. So I know for a fact I'm not having any negative factors. So I can put plus signs automatically here for our signs. So now let's think about what factors work. What factors would give us 16 when we sum them together? But remember, we have this 3x, so it's a little bit harder than that. So let's think, okay, obviously I can't put the 15 outside. That makes 0 sense. Because 3x times 15 is 45. We're already way above 16. Okay. If I put the 15 here and a 1 on the outside, we're going to get 3 times 1, 3x, plus 15x, 18x. Okay, no, that's not going to work. So I'm going to get rid of this. So now we have 3 and 5. So we have, if we make a 3x, we have a 3. I should have actually made this 14. My bad, guys. This is supposed to be a 14. Okay, so when I do 3x times 5, right, if we put a 5 here, we're going to get, sorry, not a 5 there. My bad. We're going to get 15, and then 3 here, that's going to give us 18. That's not 14. So we'd have to put a 3 on the outside and a 5 on the inside. So that would be 3x times 3 is 9x, and then plus the 5x gets you 14x. So that ends up working out. Apologies about that, guys. This is me making up a problem on the fly. But that's what you basically want to do when you're doing factoring problems like this. You want to be able to first break down your first term, your leading coefficient, right? What way can I get 3x squared? Well, 3x times x. Again, it doesn't matter. You could do x and 3x. It's multiplication. Remember, it's commutative. And then in terms of your factors, it's just seeing if you were to try out different factors, you know, which one would sum up to the value in the middle, which is plus 14. You won't get too difficult ones on the ACT in terms of factor-wise, so I think you guys should be okay. Again, apologies with this example not being 100% perfect. All right, systems of equations now. There are 3 main ways we can solve systems of equations: through elimination, substitution, and graphing. So we'll try a elimination problem first. So actually, we'll do substitution first, actually. That's, I think, is a little easier to understand. So what does substitution mean? That basically means, let's say we have 2 equations here. Equals 6. And then let's do 2x plus 2y gives us 4. Okay, so what does that mean? That means we're going to solve for one variable in one of the equations, and then we're going to plug that into the other equation. So that way we're just having one variable to solve for. And then once we figure out one variable, you can plug it into any equation, or actually in reality you should plug it into the, once you substitute the variable, you get an equation there, and you'll be able to get your answer. So here's an example, right? I want to do substitution here because I see a y by itself. So I can get the second equation in terms of x and solve for x pretty easily. So to solve for y, we're going to move 3x over to the other side. So we're going to get y equals 6 minus 3x. So now we're going to take this 6 minus 3x and we're going to substitute it right in here for the y value. So that way we get that second equation entirely in terms of x. So 2x plus 2 times 6 minus 3x. Wow, that's a pretty bad 3. 3x gives us 4. So now just distribute it first. So 2x plus 12 minus 6x equals 4. Combine the like terms, move the 12 over to the other side. We're going to get minus 4x equals minus 8, which when we divide both sides by minus 4, gives us x equals 2. So this is our x value now. And we're going to plug that back into here since it's already easy to solve for y. So y equals 6 minus 3 times 2. Remember, 2 is what we got for x. So we're going to get y equals 6 minus 6. Y is 0. And that makes sense. If you were to plug these back into this initial equation, that's what you're going to get. So you can write it as, x equals 2, y equals 0. Or you could also write it as 2 comma 0. Which makes sense because if you were to graph it, that's where your solution would be. So let's actually talk about graphing. You need to know graphing in terms of like graphing lines and stuff, and we're going to talk a lot more about graphing in a later video, but we can kind of illustrate it here really fast. Say I'm going to pick a really easy equation. X plus y equals 2, and then let's do 3x plus y equals 4. Yeah, I think that works out. Okay. So how do we plot equations? We want to get it into y equals mx plus b form. So let's solve for y in both these equations. So this is going to become y equals, subtract x from both sides, negative x plus 2. And then we have y equals negative 3x plus 4. So in case you don't know y equals mx plus b form, this is your slope. So slope here is negative 1, right? You can imagine there's a 1 there. And negative 3. And this is your y-intercept 2 and 4 for the respective equations. So if we were to graph this, and I apologize, it's not going to be perfect, but let's say we have 2, 4, 6. I really need to get better at graphing. Oh my god. And let's say we do 1, 2, like here. All right. So we're going to start at 0, 2 for this equation. And it's basically going down like this. And then you can extend it back up in this direction. Oh, wow. Okay. Obviously, make sure you're doing this with a ruler and a straight edge. I'm literally just doing this with my mouse. But now we get up to 4. We always want to start with the y-intercept. And then you're going to go follow the slope. So 3 down and to the left 1. 3 down to the left 1, so like this. Really? And then like this. Okay, this is a really bad drawing, but that's the idea. And you see they are supposed to intersect at 1, 1. That's why I picked this problem. Oh my god. Okay, here we go. So 1, 1, that's where this intersects, which, I mean, you could have solved this also through another method, and you'd be able to get that as well. But we're going to talk about graphing in a little bit. Apologies for the really bad drawing. Alright, so let's try doing an elimination problem now. So what are we going to do for elimination? Basically, for elimination, we're trying to eliminate one variable, so that way we're solving for just one variable and we can plug it back in to get the other variable. So let's say we have 2x plus 5y, and we're going to get that equal to, let's go with 12. And then we have 4x plus 3y, and we're going to get that equal to 10. All right. So at first, I would not recommend graphing or doing substitution with this because it's not easy to solve for one variable, and it's not easy to, make it in slope-intercept form. So the easiest thing here to do is an elimination. Basically, what do we mean by elimination? We're trying to let's look at each of these terms individually, right? Each of the x terms and each of the y terms, right? We're trying to find the least common multiple between these two, right? And we're trying to see how easy is it for us to we want to try to manipulate one equation by also keeping the other equation the same. So between 2 and 4, their least common multiple, that's 4. Between 5 and 13, their least common multiple is 15. So obviously it's easier to try to eliminate the x's first, because all we're going to need to do is manipulate this equation, because we already have a 4x here. So since we're adding these equations, we're going to make this into a negative 4, right? So that way we can add it through. Okay. So we're going to multiply the top equation by negative 2. So that way we get that negative 4. So 2 times negative 2, that is going to give us, well, I'll put this actually out here, negative 2, so we know. Negative 4x minus 10y equals minus 24. All right? And then we're going to be adding it to 4x plus 3y equals 10. Remember, we're keeping this other equation the exact same because we want to cancel these x terms out. So, boom, this goes. Negative 10 plus 3y. Negative 10y plus 3y gives us negative 7y. And then negative 24 plus 10 gives us negative 14. So we're going to get y equals 2. Now, in terms of plugging it back, I probably think it's easier. You can honestly pick whichever one you want to plug into. I'll just plug into the second equation for the fun of it. 4x plus 3 times 2 gives you 10. So 3 times 2 is 6, obviously. So 4x plus 6 gives you 10. And then 4x, subtract 6 from both sides, you get 4x equals 4. And then x equals 1. So your answer here is x equals 1 and y equals 2. Or you can write it as an ordered pair, 1, 2. All right? So those are the different ways to solve systems of equations on the ACT. All right, let's move on to the next topic, exponents. We're going to go through this one pretty quickly. We kind of touched on it a little bit in the pre-algebra video. But basically, exponents, right, if you have a term 2 to the 4th power, this is your exponent right here. So what's really important to go over in this section are exponent rules. Specifically, what happens when you're multiplying. So let's say we're multiplying two terms like this together, right? 2 to the 4th times 2 to the 6th. In this case, you're going to be adding exponents while keeping the base the same. So it'd be 2 to the power of 10, right? If we were dividing these, let's say we do 2 to the 7 divided by 2 to the 5. Remember, we're keeping the base the same, so it's still going to be 2, but we are subtracting these exponents now instead of adding like we did in multiplication. So it's going to be 7 minus 5, that's going to be 2 squared. All right, when do we multiply exponents together? That's when we have it as like 2, it's like power to a power. So 2 to the 5th, and let's say that to the squared power. So in this case, we're still keeping the base the same, but now we're multiplying these two exponents together instead of adding them. So we're going to get 2 to the 10th power for this example. Whenever you have a negative exponent, so 2 to the negative 3 power, you can basically rewrite it as 1 over 2 cubed, like this. So whenever you have a negative exponent, just move it to the denominator, and it's going to be correct. So same thing, 1 over 8 for both. They both work out. And then last thing, if you have like the square root of x or something, this square root, you can rewrite it as a fractional exponent, x to the 1/2 power. So it's important to know how to translate between fractional exponents and radicals. So this 2 is like what goes outside here, and this 1 is what is for the term inside the radical. So like another example, let's say we have x to the 2/3 power. 2/3 power. So we want to rewrite this as a radical. The 3 is going to go on the outside of the radical. So it's going to be like the cube root basically. And then we're going to have x squared on the inside. This numerator always stays with the term, and this outside term is what is going on the outside of the radical. We don't usually put a 2 for these type of radicals because they're square roots. If we just see this alone, we know it's a square root. But for other roots, you're going to need to put their index on the outside. Like actually like explicitly state it there. Like explicitly write it there. All right. Next example, word problem. So the key for these is just kind of understanding what the problem is saying and translating it into mathematical terms. So if you're saying like, you know, if it's like per hour, right? You're dividing by an hour. If you're doing in addition to, you're adding something. If you're taking away something, you're subtracting it. If you're putting things together, you're adding it. So being able to know these terms, like in terms of taking a word problem, just kind of break it down into its component parts and just take it and translate it into math. The easiest thing is just translate it into algebra and you'll be able to understand it a lot more. Okay, so that's the idea behind that. Distance, rate, and time, that's the last part. So distance, rate, and time, all you gotta remember is this. D equals R times T. So distance equals rate times time. And no matter what you're asked to solve for, you can easily manipulate it to find the other. So if you want to find the rate, you do distance divided by time. If you want to find the time, distance divided by the rate. So I'll give you guys an example, I guess. If we're traveling 50 miles at 10 miles per hour, what is our time? So this is our D, this is our R, and we want to find our T, our time. So we're going to just plug in 50 here, equals 10 times T, divide both sides by 10, and we're going to get 5 is what T is equal to. So it's going to be 5 hours in this case. Units are important in these problems. So this is really simple to understand. All right, everyone. So that is all the topics to go over in elementary algebra. Again, these aren't very hard. These are just a little bit of a step up over pre-algebra, but again, these ones you should be going over pretty quickly. Starting in the next section, things start to get a little bit more tough. So I will see you all in the next video. Please make sure to like and subscribe, and let me know if you have any questions. Thank you, guys.